Yes, ma'am. Yes, ma'am. Okay. Oh, okay. Oh, okay. Thank you. Uh, Good evening to one and all. Today we'll discuss about continuous fixed beam. Right. They will discuss about continuous fixed supports. Okay. How to design the fixed support, how to calculate the reinforcement. Once again, sorry. Yeah. Okay. We'll discuss about the how to create the simply supported beams and other activities. Right. Okay. So I simply share my screen. Logaraja sir, sir, please check the YouTube live also. So our voice is audible or other etc. Ah, okay, sir. Okay. Today we'll discuss about how to create the one fixed support continuous beam. Right. Okay. First of all, yesterday we'll discuss about how to create the one simply supported beam and moments etc. Today we'll discuss about fixed beam. Right. Is automatically, first of all, I simply draw the one fixed beam. Whatever is my 2D frame researcher, right? This is my 2D frame researcher. For assumption, this is the ground floor, this is the first floor, right? This is G plus 1. Okay. How to take the continuous fixed support? This all the conditions are you will be designed as a fixed supports, right? This is my fixed support, this is my fixed support. First of all, this is a column, right? This is a column, this is a beam, this is a fixed end supports, right? This is a fixed end supports. This is a column, beam, fixed end support. Today we'll discuss about how to design the one single continuous fixed end supports, right? Simply design support. Okay. How to calculate the moments and other etc. Yesterday we'll discuss about simply, this is simply support, right? The maximum moment transfer into tension zone, right? Tension zone. You design the reinforcement in tension zone also. But today we'll discuss about the moment will be carry over to tension zone and compression zone also, right? First of all, I simply draw the one continuous beam, right? Fixed end supports, right? All are fixed end supports, right? This is a two, sorry, this is a one fixed end support, right? I simply acting on this load, something like a load, 3 kiloton or 2 kiloton something. Yesterday I tell about how to take the different types of kiloton per meter, right? How to take the loads in IS 875 part 2 etc. right? In our support, how to take the moments, right? How to draw the moments. This automatically, this type of moments will be calculated in your continuous beam, right? Now understand, fixed end moments, this type of moments will be calculated in your continuous beam. See this, the beam will be higher, the column depth will be less. For simply support, the beam depth is smaller, column depth is little bit higher, right? That is the different. What different means? This moment value do not carry over to column, but simply supported the corner is 0, right? The column will be, but you go for continuous fixed support, this moment, some of the moment is there, right? The moment is carry over to column. So design for column means you take the moment also. to design the moment takeover to column, that is called fixed and continuous beam, right? Then you go for shear, same like a shear. Yesterday we'll discuss about, right, a shear, same, right? This is our continuous support or any fixed support. This shear is the same like that. Same like that, you will be calculate the shear also, right? Same yesterday, same procedure will be calculate the shear and the moment in your fixed end support, right? Fixed end support, you calculate the moment and others, etc. Today we'll discuss about same path, how to calculate the moments and shears in continuous fixed support, right? Next of all, how to calculate the reaction forces in our beam. Okay, first of all, I simply create one continuous beam, right? Okay, for assumption, this is our fixed support. This is also our fixed support. This is also our fixed support, right? I simply separate the three beams. This is a beam number one. This is a beam number two. This is a beam number three, right? These are the three beams. I separated into different load cases. The beam number one acting on 20 kilonewton per meter, right? 20 kilonewton per meter. Something. This is a 15 kilonewton, right? This is a 15 kilonewton per meter. Then this is also 10 kilonewton per meter, right? The 10 kilonewton per 15 are brick loads. How to calculate the brick loads means based on IS 875 part 2, part 1 code book. You refer that, you will be calculate the values, right? Now understand, you will be take the three beams in fixed support. The loading condition of 20 kilonewton, 50 kilonewton and 10 kilonewton. That facing also difference. There is a 4-meter beam. I take this is a 3-meter beam. Then is a 4-meter beam, right? This is a different sizes. This is a 1, 2, 3 beam numbers, three different load cases, and three different sizes also, right? Yesterday we'll tell about thumb rule, right? 1 feet equal to 1 inch. How to calculate the thumb rule, right? 1 feet equal to 1 inch. The 4 meter means 12 feet, right? 12 feet means 12 inch. This is also 3 feet, convert into meter, 10 feet something, 10 inches, right? Now understand this. Yesterday we'll briefly discuss about how to calculate the thumb rules and brick loads and etc, right? Okay. Today we'll create the same problem in StatPro. Now understand, 20 kilonewton, 15 kilonewton, 10 kilonewton. These loads are come from IS 875 part 1 code books. The sizes also different. This is a 4-meter beam, the 3-meter beam and 4-meter beam, right? Okay. Then how to draw this type of beams? There are this is StatPro. Three methods are there. Yesterday briefly discussed about snap node method, geometry method and structural wizard method, right? Today will discuss about same method, geometry node method, right? These are the three coordinates are there, x, y and z, right? Yesterday will briefly discuss about x, y, what is meant by x, what is meant by y and what is meant by z, right? Simply tell that this is a one plan, right? X is a that distance and z is a width distance and y is a height, right? That is a simple. Okay, then this is all the node points, right? These are node points. How many node points? 1, 2, 3, 4 node points, right? These are all supports are node points. There are 4 node points, 1, 2, 3, 4, right? The first node point x value is anyone? The first x value 0, right? Y also 0 and z also 0. Next point, second point is a 4, 4, right? 4, 4. Oh yeah, 1 second, sorry. 4, 0, 0 0. The next x point is same, not 7, correct. How to make the 7 means 4 plus 3. Add this point. This is a plus 3. This is the next point, right? This is the fourth point, 4-meter beam. This is the end point, second point, right? How to add the point means 4 plus 3, right? Equal to 7 meters. Next point is a 7. X, y also 0, z also 0, right? Next x point is this point, last point. Last point of x is 11, right? Total distance. Our total distance is 4 plus, this is a 3, right? 3 plus the last point is a 4 meter, right? Totally 4 plus 3 7, 7 plus 4 11. That is our x distance, right? Simply click this 11 0 0. That's send, right? Now I simply created the 4 node points. The beams are 3 beams, but node points are 4 points, right? 1 2 3 4, right? Then close this dialog box. Then see this, automatically the 4 node points are there, right? This is the first step. I simply created the 4 node points. The first node point, second, third, fourth. Sometimes the node points are invisible, right? Sometimes how to visible this node points? Simply right click on your mouse, go to labels, then go to node points. I need the node number also, right? How many nodes in my building? Simply click this node numbers, apply, okay. See this, sometimes your node point will be invisible. Simply visible this node points, go to labels. I need a node number also. Simply click this node numbers, right? This is the first step. Then how to add the beams? How to add the beam? Same procedure. Simply go to geometry, go to add beam from point to point, right? Click this point to this point, and this point and this point, right? These are the beams are 3 members, but nodes are 4 numbers, right? These are the joints. 1 2 3 4 nodes, and beams are, how to find the beam numbers? Simply go to right click on your mouse, labels, then go to beam members, right? Beam numbers, apply, okay. This automatically 1 2 3, right? 3 numbers are beam numbers, node points are 4 node points. Our first step is over. The second step is go to general. First step, anyone? There are 4 steps are simple steps. First step is a material, second step is a property, third step is a support, and fourth step is a load and definition, right? Correct. This is the basic steps for you design any steel structure, concrete structure. Any structure means you simply create these 4 steps are main steps. One is a material, another one is a property, support, load and definition, right? First step, simply click this material, then go to concrete. I need a full beam as a concrete material, right? Go to assign to view, assign yes, my full beam as a concrete, right? The next step is a property, right? uh, you take a one small residential building or any commercial building, you simply analyze the beam. It's take a 4 or 5 numbers of sizes is there, right? You analyze the slab or column, anyone, you take a small residential building, the 3 or 4 types of sizes of beams in our building, right? Okay, these are 3 beams. I find the 2 sizes of the beams, right? I find this is a 4-meter beam, this is a 3-meter beam, this is a 4-meter. How to find the depth, breadth and depth for my beam, right? This is a property dialog box. Then go to define, right? Then go to define, then rectangular, right? Rectangular. This condition is equal to our wall thickness. Our wall thickness is 0.23, right? Our beam depth is, one is a theoretical value, another one is a thumb rule is there, right? Thumb rule, what is meant by thumb rule means 1 feet of beam equal to 1 inch, right? This is a 4 meter, right? 4 meter is converted into feet means approximately take into 12 feet, right? 4 3 is 12 feet. 12 feet means 12 inch, right? 12-inch depth for my beam, right? Simply go to define rectangular is a 230 mm into 0.3 is a 12-inch means 1 feet is add. The next one is a 3 feet, right? This is 3 feet. Convert into meter, approximately take a 9 inch or 10 feet or 9 feet, right? I take a 9 feet. 9 feet equal to 9 inch, right? 9 feet equal to 9 inch. My beam thickness is convert into mm means 230 mm. Simply go to define rectangular. My width also 230 and breadth also 230 as per thumb rule. Thumb rule, simply you go for one beam, 1 feet beam equal to 1 inch depth. That is a simple thumb rule. You will calculate the theoretical book value also. Some of the thumb rules in working on condition in site condition also, right? Okay. I created two sizes of beams, right? Two sizes of beams. This is a one size of beam and this is a one size. These are same size. The center beam is a different size, right? How to apply this different sizes of in our beam? First beam, I apply the 230 into 300. This is a four condition are there. One is assigned to selected beams, other one is assigned to view. Previous day will be only using for assigned to view, right? What is meant by assigned to view and assigned to selected beam means simply you click this assign to view, assign. Three beams are same size, that is called assigned to view. I need this beam and this beam are same size, right? Simply click this beam and control click this beam, right? Then automatically is converted as a assigned to selected beams, right? Assigned to selected beams, assign, yes. This, sorry, yeah, right. Select this and select this. Simply go to assign, yes. This is automatically created as a one R1 is a material property 230 by 300. I need this beam and this beam. You simply click this assign to means the three beam sizes are same size. I need only this corner beams are 230 by 300 means you simply click this one and press control and select this, then go to selected beams. And center beam I need 230 by 230. Simply click this beam, then assign to selected beams. Assign, yes, right. This is the method for give the property for different types of beams in your section structure, right? Simply give the assign to means assign to view, apply all the properties for your beams and columns. I give the different beam sizes for my floors and different beam sizes for my columns and etc., right? Simply select your beams and simply go for assign to selected beams, right? Our second step is over. Then third step is support, right? I take a continuous fixed support conditions, right? Continuous fixed support conditions. How to create the supports? Simply go to support dialog box, then go to create, right? Then go to create fixed add. Automatically the support fixed support 2 will be added. How to apply this node points? 1 2 3 4 supports, right? How to apply this? Simply select this. First of all, this is a beam crusher, the node crusher. You working on the node points, but you select the beam crusher. The beam crusher only select on beams only. The node crusher only select on node points, right? This is the difference between beam crusher and node crushers. I simply select the all the node points, then go to assign to selected beams or assign to B, no problem. Assign yes. This automatically our three beams and fixed support it will be created, right? Fixed supports it will be created. Our first step material step is over, the property step is over, then support it will be created, then load and definition, right? Load and definition, the yesterday we'll discuss about how to take the dead loads as per is 875 part 1, right? I take the brick loads and others, etc. Right. I one more time I will show that code book. That is a code book for dead loads. Dead loads are self-fade. You go to live load means you go for IS 875 part 2. Right. This is a IS 875 part 1. This code for dead loads and unit weights. You go to take any sulfates for the bricks and other aluminum material, glass panels. I need for big unit weight. Simply search it, automatically it will be created, right? See this dry clean river. This is steel property also, right? The heavy weight. I need this brick properties. All the sulfates are given in this IS 875 part 1. And you see this automatically. This is a common burnt clay bricks. Is the weight is a 18.85 dead load. This is engineering bricks. I take engineering bricks 23.55, right? This is a kilonewton per meter cube 23.55. Then how to convert into kilonewton per meter. It's a formula is there. Sulfate into wall thickness into height of the wall into per meter. That is a kilonewton per meter. The wall thickness converted into meter, right? First of all, how to create the load cases. First one, click this load case details. Go to add, right? Then go to first load is a dead load sulfate, add. The another one is a live load for brick loads, add, close. Sometimes the brick loads are also dead load. I give some difference means I take a live load as the brick load, right? The brick load also dead load, right? Simply go to load case 1, right? Load case 1, add. I go to simply add my sulfate, automatically the stat pro will be taken. Simply go to sulfate, add, close, right? How to apply the sulfite for my beam? Simply click this sulfite, then go to assign to view, assign yes. This automatically our first step is over. Simply assign my sulfite for my beam, right? The next, how to assign the brick loads for my different beam in different load cases, right? First of all, this is our beam, right? The 4 meter 3 meter span is created, then load is 20 15 10, right? How to create the 20 kilonewton, 10 kilonewton and 10 kilonewton, right? Simply go to load case 2, then go to add. You already studied in MOS, right? You calculate the simply supported beam and shear force, bending moment and etc. The bending moment and etc. The same as the stat pro is follows a gravity, right? Your download direction will follow as a minus. Same like a uniform distributed load. The brick load is a uniform distributor like UDL. Your brick load is a UDL. Simply go to uniform force, right? Kilonewton per meter. My first load is a 15 kilonewton, and also I add the second load 10, sorry, 15, 20 15, right? Okay, 10, add. First is a 20, second one is a 15. How to edit the loads, right? How to edit the load? Simply click this, go to edit option. My first load is a minus 20, change it. Next one is a 15. Simply click this, edit the minus 15, right? Change. This automatically, this is 20 15 10. Then how to apply my UDL for my three different beams? You go simply select first one, right? UDL is 20 kilonewton. You go to assign to view, the three beams are apply on same load. I need this beam only. Simply select this beam, then go to assign to selected beams, right? Assign to selected beams, assign yes. Then go to loads, reduce the size. The second beam is a 15 kilonewton. Simply select this beam, assign yes. This next one 10. Simply select this, assign yes. This automatically it will be reduce the sizes for this beam size, load sizes, right? This higher load is a 20 kilonewton, this is the 15 kilonewton, this is the 10 kilonewton, right? These are the three different load cases. How to see the load values, right? How to see the load values? Simply go to right click on your mouse, labels, go to load values, right? Go to load values, apply OK. This automatically your loads are visible in beams. Okay, our four steps are over. First one is the material, the second one is the property, and the third one is a support, and the fourth one is a load, right? I give this load for cell 5 and other three brick load. Next one is a combination. You already studied in books into factor of safety into 1.5, right? 1.5, that's a combination. How to combination in this step row? Simply go to lowercase details, go to add, right? Go to add define combination, right? Define combination, the two loads are there, this type converted into this space, right? Simply click the double arrow, so automatically this side into this side. By factor of safety in concrete 1.5, 1.5, right? Add, close. This the normal load is a 20, 15, 10, right? Our UDL load. I converted as a factor of safety into 1.5. See this, automatically this load convert into 30, this 22.5 into this is the 15. But I apply the 20, 15, 10. Is it automatically you simply give the 1.5, the stat will be automatically converted into 1.5 times of the load, right? That is the advantage. See, this is a in factor of safety. You load into factor of safety, your load into 30, 22.5 and 15, right? The next step is over. Then final step is the analyze, right? In the modeling stage, first step is the material, second property, and third support, load and definition is over, and the combination is over. Then next one is the analyze. Simply go to modeling, go to analyze and print, add, close. The bottom is the bottom bar, analyze, run analyze, save, right? Okay, the warnings is there. Sometimes will be warning will come, you will be rectify your warnings. The error means you will be change the structure also, right? The property for number 2 duplicate last values used, there is a no problem. So sometimes your instability joins in this 2D frames also, it will be 3D frames, the error will be not come, right? Okay, our analysis will be completed, right? Our analysis part will be completed. Then how to see the bending moment values and shear values, etc., right? Simply go for post processing, right? Post processing. I need the bending moment value and shear value and reaction value. Is loads. How to select the loads? Load case 1, 2 is there and combination. Which load you will be select for design? Which load? Anyone? You take a load case 2 or 1 or combination load. Yeah, why? The combination load is the maximum load. That is the concept. You yes, correct. The maximum, you take any building, you design the maximum load. The combination load is the maximum load. So design the combination load. Simply click OK, right? The first of all, see the bending moment. Simply go to MZ is the bending moment. This automatically. This is our bending moment. There is some difference. What is the difference between different types of bending moment in this fixed condition, right? This is different types of beams supported for fixed conditions. This is a moment. The simply support is different. The fixed condition moments are different, really different, right? Okay. This is our moment. The simply supported means only in tension zone, right? Only in tension zone for moment. Is a fixed and continuous means the moments will come from compression zone also in two sides, right? What, see this difference. This moment is there, this diagram and this diagram. What is the difference between the moment diagram? What is the difference? Simple. The load is acting on the beam, right? This is a higher loading. So the bending will be high. This is smaller loading. This is also smaller loading, but beam depth is high. So this is bending is small, right? That is the difference. The load will be high and bending is small. Then how to see the values? Simply go to result, view value, beam result. I need a end and a mid span. See this. This is a bending form. Is a you simply see this. Simply supported means you will be moment only acting on a tension zone, but you will be fixed. You framed such a the moment will be acting on the compression zone and tension zone also, right? The sum of the companies having the cross section in three stages, right? Simply supported means you give the one cross section, but see this. This is our longitudinal simply supported beam, right? Yesterday we'll discuss, right? I cut this cross section. See this automatically. This is a hanger bar straight for simply supported, and this is a tension moment bars, right? Tension zone moment bars. We will be go for fixed condition. This is one of the fixed beam, right? This is a fixed beam, one beam. This is a fixed condition, right? The fixed condition. Moment, see this moment value. Moment value. This is a compression zone moment is there. Tension zone also moment, and compression zone corner end supports also moment, right? How to create the cross sections in this fixed support? You take the two cross sections, minimum two, maximum we go for three. How to take the cross section? Take this corner and center and this corner, right? Okay. For simple example, this is a A, right? The cross section A, this is a B, this is a C, right? Okay. Anyone, I take the cross section for A. The compression zone is the tension zone. Compression zone is a rod will be there or no rebars. Anyone? In compression zone is a top zone. The any rebars in this compression zone or no rebars. No hanger bars. Its moment is zero, you provide the hanger bars. But in the fixed support, it has some moments, right? Fixed support, the compression zones are some moments. So you design for provide the rod for compression, right? You provide the rod for. But this portion tension is a no moment, right? Zero moment. So you provide the side bars, right? Do not need extra bars, right? The tension zone is a no moment, so do not need extra bars. You provide the main bars also, do not need extra bars, but is a tension zone, you provide the extra bars, right? The B section, this is the B section, the B cross section, right? B cross section. The extra bars is provided for compression zone or tension zone. Anyone in this B section? Correct. Tension zone. Why? The moment is high in tension. So you provide for extra rebars in our tension zone. But compression zone, same straight bars, right? You simply go to C section. This is the cross section C. Which zone we will be provide for extra bars? Tension or compression? Compression, yeah. Moment will be correct. The moment will be high in compression. So you provide the compression zone, right? You have one doubt, right? This is how to find the minimum bars for tension zone and compression zone, right? How to find the moment for tension zone? Is a tension zone? The moment is high, you provide the extra bars. This area no moment. How to provide the minimum bars for my tension zone and compression zone, right? Simple. Simply you refer the IS 456 code book, right? This uh, once again I will show my PPT. Is PPT is the best. Okay. I show that in this PDF also, right? IS 456. The IS 456 refer that the condition is there, beam conditions for minimum tensile reinforcement and minimum compression reinforcement in this IS 456. Yeah. Yeah. This is the minimum reinforcement for your tensile zone and compression zone as per IS 456. This is tension zone reinforcement, minimum reinforcement is a not less than this condition, right? For what you will be simply see this in this image, right? In our image there's a no moment in this place, right? In this moment no moment. I do not need extra bars. How to provide the minimum bar means simply refer this IS 456 page number 47. There is a minimum criteria, minimum bars for tension zone and compression zone also. Minimum maximum area of reinforcement for not exceed 0.0 BD. This is a compression zone minimum reinforcement, right? Now understand how to calculate the minimum reinforcement for compression zone and tension zone as per IS 456 page number 46. You will be studying that page number 46. You will understand this concept how to provide the minimum tensile reinforcement and maximum reinforcement for this bar, right? Now understand. This is the extra bars provide on a moment condition, but minimum bars provides on as per IS 456 code book, right? That formula you provide the minimum bars for compression zone and a tension zone, right? Now understand. This is the basic concept for and cross section also. You're creating the same cross section, right? This automatically this moment is high in 43. This is 22, 43, 18, 9, 12 and 23, right? Okay. Then how to calculate the moment values in fixed end condition means simply go to W L square by 12, right? Or W is 20 into 4 into 4, right? 20 into 4 into 4, 12. Okay. Okay, some problem. I tell about how to create the same value from this manual calculation also. I tell about next class how to calculate this and other, right? The moment formula also. Okay, then this is a moment condition, right? You simply calculate this AST value, directly take this moment condition as a 43. You simply calculated this value in this mu equal to 0.87 Fi formula. You take the AST value also, right? Then how to see the shear force? Simply click this Fi direction, right? Fi, then go to result, view values, right? Go to end midspan. This automatically the moment shear will be high in end corners, right? You studied in the shear, right? This is a beam cross section. The shear will be high in end of the beam column joint, right? Okay, for example, you provide the stirrups, right? You provide the stirrups, the center portion, the stirrup spacing is high, more than 200 mm or something, right? But the corner, sometimes you provide the stirrup spacing are 160 mm. Why? Anyone? The center spacing is a 200. Correct. The shear force are higher, right? Shear force in higher in corners, so stirrup spacing will be less. But the shear force is no shear force in mid, so you provide the longer spacing, right? The same procedure. The shear is high in this corner, you provide the stirrup spacing is higher, right? Then this portion you will be provide the this type of zero and this portion, right? Okay, then how to see the reaction forces? Simply go to reactions, right? See these reactions. That is the reaction. The beam load carry over to columns, right? This beam load, this type of beam loads, combination load, how much? 65 kilonewton carry over to column and 43 moments. This moments, the beam moment will be carry over to column, right? This beam moment is carry over to column, this load are carry over to column. This beam is load carry over to y, and this moment is carry over to 25 for this column, right? This column is load is carry over to 71, this moment is carry over to 5. Yeah, 5. And this beam moment load will be carry over to this column is 35 kilonewton, and moment is carry over to 23, right? You will be studying this column, right? Tomorrow I tell biaxial, uniaxial and axial column. These are these columns will be designed on load and moment also, right? The conditions. See this column, the beam transfer to column is automatically the load is 65 and moment also there. This column 101 so high, this beam half portion will be transferred to column, this beam transferred to column, so this is a high, and this beam is transferred to this half and this half, this 71. This column is this half portion only transferred to column and moment also, this half portion transferred to column, right? Now understand, you design the column means you take the moment and load also, right? You simply see this moment distribution diagram for this reinforcement details for tension zone and compression zone. Then you go for shear force for stirrup spacing, and the reactions means how many loads transfer to beam to columns, right? You design the column means you convert the load and moment also, right? There's the two conditions to design the columns, right? Okay. Now itself is over. Our modeling condition is over, and post processing second step also over. How to see the moments and shear force and reactions, right? The next one is the design procedure, right? How to design the how to design in your beams, right? How to design in your beams means simply go to modeling, right? Simply go to modeling, then go to design, right? Then go to design. Simply go to modeling, then go to design, go to concrete design, right? Then go to design, then go to concrete design, then current code as per IS 456. Simply go to modeling, go to design, our current code as per IS 456. And then go to 3R main steps, select parameter, define parameter and commands. These are the three main steps. One is the select parameter, means whatever you need to design your beam, right? Whatever you need. I need a grade of concrete and grade of steel only I will be need to design. Simply select the select parameter. You select this side, it's transferred to this side, right? Yeah. Then I select the two parameters. One is the compressive strength of concrete and main reinforcement and shear reinforcement, right? I take a 3 only, right? I take a 3 only, then click OK. The select parameter is a whatever you need, you will be simply select for this beam. Next one is the define parameters. The define parameters is that you click this values for your beams. I need a grade of concrete is M25 and its main steel and F secondary. I need a grade of steel. This is a kilonewton per meter square. I need a newton for mm square, right? How to change the units? Simply go to tools, right? Simply go to tools, go to set current input units, right? Set current input units, go to millimeter, then Newton, right? Then Newton, click OK. Then go to define parameters. Automatically unit will be changed into Newton per mm square. Our grade of concrete is M25 and then steel is Fe415 and then our shear is Fe415 and I simply create the grade of concrete main and secondary. Then how to apply your grade of concrete and steel etc. in this your beam? First of all, simply select your grade of concrete, right? Then go to assign to view. Three beams are same grade. Assign to view, assign yes. The next one is a grade of rebars, Fe4 and 5. Assign to view, assign yes. Next one here, assign to view, assign yes. The first step selection parameter is over. The second step is the define parameter, that is the over. The third step is the designing of beams, right? Designing of beams. Simply go to commands, go to design beams, add and take off, right? Takeoff is a quality for volume of your beam and weight of your rebars, right? That is the takeoff. Simply add. The stat pro will calculate the your volume of your beam and rebar weight also, right? I create this beam design, then I apply for my beam design. Simply select this, go to assign to view, assign yes, right? Then not visible. Someone has present my screen. Once again, I will. Yes, yes, sir. I will share. So now it's visible. Oh, yeah. Simply click this designing of beams and simply apply. And then final step is the analyzing of beams, right? Simply go to analyze. Sorry. First of all, close this previous analyze. Simply go to analyze, run analyze, save, right? Okay, sorry. I do not select this Indian code. Once again. Once again, please for only 2 minutes. I will same as I prepared. First of all, you select this code, right? That is a problem. Yeah, I select this code, Indian design code. I simply Yeah. Simply go to analyze, run analyze, same as the procedure, right? First of all, you simply select this codes, right? Then simply go to view output file, done, right? Simply go to result, concrete design, right? Our beam is a three beams, right? One is a beam, one is a size, is a length, is a grade of concrete, grade of rebars, and size of the beam and cover, right? This is our property: top reinforcement, bottom, and top, right? Anyone understand this concept, right? The top reinforcement and bottom reinforcement is a correct or wrong? The top reinforcement is highest in AST value. That's a correct or wrong? Why? The moment is, yeah, higher in top, right? That is correct. In compression, simply go to in mid means the automatically the high in tension, right? The small amount, this is a 43, right? So 22, so you calculate the AST. Then you go to corner means automatically the compression is high in moment, so automatically the AST will be calculated, right? You simply go to take a rebar, the top zone is calculated the 7 bars, and 2 bars are minimum bars, right? Then you go to bottom layer, the 4 bars in this tension zone, right? Now understand how to see the result values. Understand? Yes. Then you are go to shear values, right? Ah, shear values, the two-legged steps, 8 mm dia. See this, the corners are you provided the 190 mm center to center spacing, but your center is the 200 mm spacing, right? That is the difference. Why? The corner has provided the 190 mm, the mid span is provided for 200 mm. Anyone? Shear force maximum in beam column joints, right? Mid in 0. So same as follow in this shear values, right? This is a beam 1. Next to go to beam 2. Same as see this our AST value, then center value, then AST values, right? The beam layer diagram. Then same as see this automatically. This layers, and then same result, and then go for our volume of the concrete is 0.7 meter cube, right? Total volume. How to calculate the volumes? Our length into breadth into width, 4 meter into 0.23 into zero point 0.3, right? There is a total volume for 3 beams. There is a total weight for my beams, right? Okay. Now the beams are passed. How to find my beams are failure, right? How to find the my beams are failure? First of all, I simply go to modeling, general, load and definition, right? Load and definition. I simply go to increase my load, right? I change my unit. First of all, I change this unit. How to find the my beams in failure, right? Simply go to load and definition, go to 20 kilonewton per meter, right? See this, I simply 50 kilonewton, right? Change, yes. This is also add into approximately I take 40 kilonewton, change. And this is a go to add, I take this 60 kilonewton, right? Change. Then go to analyze, sorry, first of all close this dialog box, then go to analyze, run analyze, save, right? Then go to post processing, combination load, check the bending moment values is so high, then to see the reinforcement details, simply click this two options is there, click this beam, right click, see this concrete design, right? Concrete design of this beam, concrete design and concrete design, right? But this beam is no concrete design, so the beam is not taken that so much load for this beam. Now understand, our beam size is point, this beam will be take that load, right? But see this, go to once again I go to analyze this. I add the extra loads, right? The two beams are passed, but the corner, the third beam are failure. Why? The load will be high, so third beam will be automatically failure. So increase the size of your beam. This is automatically our beam one. AST value, see this automatically. Previous only just 500. Now itself the AST value is 1366. Why? Why the AST value is high? Anyone? Ah, the loads are high, so moment will be high. Your AST value will be high. These are the three links. Load will be high means automatically the moment will be high. The reinforcement AST will be high. The rebars will be high. Right? This is linked steps. Load, moment, AST, and rebars are high. Right? Next one same bars and shears also. Right? This is a beam two. Right. Our beam 3 is a failure. See this, the section will be fail on designing section. The nominal shear force exceed the limit, right? The beam will be failure. The third beam do not take that so much load. How to pass that third beam? Beam size is 300, right? How to change the beam size? Simply click this. Go to, first of all, I create another one size. Simply go to define rectangular 0.23 into 0.38, add, close, right? I select this beam, assign yes, then go to analyze, close, analyze, run analyze, save. View output file, done. Result, concrete design. See this, automatically our beam size will be pass, right? Now understand, at the pace the beam size will be failure, the load will be high. Now automatically the beam size will be pass. That is a condition. Once you fail in your beam in that, you will be load will be high, so beam depth will be smaller. That is a one condition. So many condition is there. There is simple condition, simply increase the beam depth, automatically your beam will be pass, right? That is the one condition to failure beam into pass section, right? Now understand how to pass this beam section. These are automatically it take this load, right? The heavy load, so 230 by 300 section is failure. I change into 230 by 380, the section will be passed, right? Okay, next one is a concrete design. This is also same design, right, but is taken into divided into 12 parts. This is the you take the bending moment into this three direction, you convert it into 12 segments in this concrete design. You take the bending moment, sorry, you take the concrete detailing diagram also, right? You take the concrete detailing diagram also. How to design the beam in this concrete design, right? Simply click this concrete design. Yeah, this is another one. You design the concrete beam or any one, right? The first step is a create the envelope. Second step is the members. The third step is a group and brief, and the fifth step is a design, right? The step one by one, there is a envelope, there is a member design, then slabs, then briefs and groups, right? Simply go for envelopes, right? Simply go to envelopes, go to new envelope. I create a one, right? Okay, automatically my combination load is there. I do not have a combination load. I have a single load, means simply untick this. I have a combination load. Simply select it this side to this side. Click OK. So automatically the envelope load case is created, right? Envelope load case. Second step is a member. Which number you will be design? Go to member. I design this member, select this member, then go to members, go to auto form, right? Go to members, auto form, automatically M1 is a member. See this, automatically the member will be there, right? Then third step is the group and briefs, right? Third step is the group and briefs is for only beam and column for IS codes. You will be design the slab also as per British code, right? As per British code, simply go to first one is a brief, right? Simply go to new brief, create any name. I create a beam, right? Beam. My design code is a IS456, right? IS456 for my concrete design. My design type is a beam. Click OK. Once you click this, this is also another design. You create the top bars and bottom bars, minimum cover. This is segments. My beam, this is a 4 meter beam. This beam is I divided into 12 segments, right? The beam is divided into 12 segments for my shear and moment also, a design for torsion also. My grade of concrete is M20 or M45. We go for M45. This is a M25, right? Main reinforcement. The top bar criteria I provide the max minimum size for 16. The maximum size for I provide 20, right? Link hangers is a 8 mm dia. Bottom bar size is a 16 and sorry 20, right? I change this size. The minimum sidebars means more than 70 mm. You provide the sidebars, right? My main bar type is FE 500. I change this FE 500, right? Then go to shear force. You need the shear center line of the support, right? Shear size is the 8 mm bar, 2-legged steps and spacing. The shear rebar size is the FE 415. Simply click OK. Simple. Simply put values only. Whatever you need, simply put values. Then click OK. Then go to new design group, right? New design group, same. Already you created that beam name. New design group, OK. Automatically it's created as the new brief and new group. First one is created as the envelope member. Third step, group and briefs are created. Then design the beams, right? Next step, simply select the beam, right? Simply select the beams. Go to right click, right? Right click on the beam, then go to a new design group, right? New design group. My name is a beam design group 2. Okay. Automatically it's create that. Sorry. Ah, no problem. Okay. Then you select this, complete this design group and briefs. Simply go for mode. Okay. Simply go for mode. Go to member design. This automatically once you go for mode, you go to member design. This automatically design span type is there. How to design the beams? Simply select this beam, then go to new design group. Sorry, add member to second one. Right click, add member to design group. Simply select it. Click this add. Automatically, simply you add this design is a none, span one, beam type, hanging and sagging fail. Now I'm not design now itself. I simply add this beam, right? Add this beam. Simply click OK. Then I design this beam, right? Simply go to design. This M1. I already created the member for M1. I select this M1, then design. This automatically the beam will be okay in sagging and hanging. Shear bars also. Sometimes you will be fail also. You will rectify the structures, right? Shear by depth values are okay and shear bars are okay, right? Now understand. This is the main concrete design. Sometimes hanging or sagging you will be failure. You will be restructure your beams and others, etc. Shear bars are failure. You restructure and span by depth ratio also, right? Okay. Now I decide how to see the bending moment, shear force value, and etc. Right. Simply go to main reinforcement. That is a bending moment. Same like that bending moment diagram. Right. See this hanging and sagging moments. Right. Already studied. This moment is divided into 12 parts, right? This automatically the 4 is divided into 12 parts is divided into 12. See this moment 103.0 meter. This is a 33.53 moment and 17. This is no moment for this compression zone. This is a tension zone, right? This is a moment is there. That is the AST required. This is the AST is 972. 618 required. Our bars is bottom bars are 320 and 320 bars. You provided this bars for your layer. Then also same as a top layer bars also you provided the same as this follow. You divided into 20 posts, 20 segments or 15 segments or any. You go to sagging. The sagging automatically for moment is a zero, right? Is a bottom. The moment is a zero, center portion will be high, right? Automatically the bar will be comes, right? This is a reinforcement seeing in bending moment for this concrete design. The next one is a shear reinforcement. The shear values. This is divided into 12 segments. The first is 0. Our shear is a 154.88 kilonewton. Our shear stress is a 2.851, right? Then 0.33. Mid 2 meter is 2 meter is a 0. This portion, right? This portion is a 0 shear. Then this portion is a high shear, right? 0. The 0 automatically one. The end is a high. This automatically our end is a high. The mid portion is a 0. See this differentiate between this method. You will be see the values in this concrete design. You divided into 12 or any parts, right? Okay. So I need this shear values for this beam single. You design this beam also, this beam also, right? Then how to export the this diagram longitudinal and cross section, right? Simply go to schedule option, right? Automatically cut into three sections, right? Simply go to schedule. I told that, right? Our simply supported beams are three cross sections, one two three, right? So automatically the stat pro are taken into three sections, right? Three sections. The longitudinal section is the cross section directly exported into AutoCAD. Also how to increase the sizes? The A2 I simply increase A3, right? See this automatically simply A3 will be size will be increased. So automatically DFX format is there. Some DFX format is AutoCAD format. Okay, simply okay. So automatically this save into DFX format. You simply open in AutoCAD also, right? Go to schedule. You take the cross section longitudinal per beam and column also, right? This is a bar sizes and this is a bar length also. Scheduled bars, you take the bar length. How many meter you will be bar length is you will be take number of bars m20 20 and total bar sizes. T18 bar is a 53 numbers of bars you will be needed. T20 T20 and length bar length the 2 2.9 meters. T20 total bars you will be at the 8 mm dia bar is a 9.975 meters, right? This is shape code, the mm, right? Now understand how to design the fixed beam in StatPro. First step is the general. Go to material, property, and support. You design this section, or otherwise you will be design this concrete section. You take the segment in 12 or 20. You will be see this bending moment value, shear values, and also export the AutoCAD diagram, detailing diagram to AutoCAD. You take the how many number of bars for your beam and the length of the beam, etc. Right? Now understand how to create the beams, right? Anyone for detailing what type of code books we will be refer? Anyone for detailing? For detailing, what type of code book? Which code book you will be refer in detailing process? Anyone? File no. Yes, one. Yeah, SP34, right? No, no, I not in detail detailing. The detailing for normal beams and columns, slabs, footings, etc. Yeah, SP34. Tomorrow I show that code book. SP34 is the detailing code book for your normal beam, column, slab, footing, how to create the sheets for your diagram cross section. That's all. SP34 is a you download in internet also. SP34 is a detailing reinforcement code book for your framed structure and steel structure, etc. Right? You will be refer that code book. You will be create that on this detailing, right? I asked the one question, uh, how to find the ties for the 12 bars in one column. One column is there, and that column have a 16, 12 number of bars, right? How to find the ties for this column? The normal you studied in this book or anyone here two-legged and two columns are there. You how to find the 16 number of bars? Some columns have 16 number of bars, 20 number of bars. How to find the ties for the 16 bars and 20 bars? Anyone? Okay. You refer the SP34. It clearly is there. How to find the 60 numbers of ties? Tomorrow I will be show. The SP refer the SP34. You find the 12 numbers and 16 numbers, the L shape of columns, and T how to find the reinforcement for T shape and the L shape of columns. Right. Okay. Now understand how to create the one fixed continuous beam. Right. Okay. Now itself I complete this section now. Any doubt, we will ask me. Tomorrow we'll briefly discuss about how to create the 3D section and some rules are there. Column fixing, beam fixing, slab. I tell on tomorrow on code books also. IS 875 part 2 SP34. Some of the code books are there. Okay. Now I complete this section now. Any doubt, you'll ask me. And please fill your valuable feedbacks also. I'm not think more. SP34 is the nowadays now itself the SP34 is there, ma'am, for detailing. Yes, ma'am. It's for all detailing for beams, columns, etc., piles and stresses and creating on sheet detailing, etc., ma'am. Thank you. Hello, Raja sir. Please put the feedback on YouTube live also. Okay, sir. Any doubt, we ask me.
begin the session, sir?
Okay, ma'am.
Okay.
Okay.